Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve International A-Level Edexcel M1 January 2022 paper question number 7. Alright, so the question says that a particle P of mass 4 mkg lies on the surface of a fixed rough inclined plane, and the plane is inclined to the horizontal at an angle alpha with tan alpha is equals to 3 over 4. And then it says that the particle P is attached to one end of a light inextensible string. The string passes over a small smooth pulley that is fixed at the top of the plane. The other end of the string is attached to a particle Q of mass mkg, which lies on a smooth horizontal plane. Okay, so the particle Q is on a smooth horizontal plane and P is on a rough inclined plane. And then it says that the string lies along the horizontal plane and in the vertical plane that contains the pulley and a line of greatest slope of the inclined plane. And the system is released from rest with the string taut as shown in figure 4, and the particle P moves down the plane. And the coefficient of friction between P and the plane is 1 over 4. So for the motion before particle Q reaches the pulley, in part A, we need to write down an equation of motion for the particle Q. So if we consider the forces acting on the particle Q, so as we know the fact that the mass of the particle Q is mkg, so weight is acting vertically downwards mg Newton. And since the particle Q is in contact with this horizontal plane, so here we have a normal contact force acting perpendicular to the plane. And here the particle Q is connected with the string. So when we are referring to particle Q, so the tension in the string is moving away from the particle Q. The tension always moves away from the point of reference. And since the horizontal plane is smooth, here we don't have any friction. So we won't have any friction acting towards right. We need to make an equation of motion for the particle Q. So we are going to say that T is equals to mass times acceleration. As simple as that. All right. So this was the answer of part A. And then in part B, it says that find in terms of M and G the tension in the string. Okay, we need to leave our answer in terms of M and G. So now if we consider the forces which are acting on the particle P, so as we know the fact that the mass of the particle P is 4 mkg, so weight is acting vertically downwards 4 mg Newton. And here we would have the components of the weight which are acting perpendicular to the plane and along the plane. So first of all, this angle would be alpha. So the component of the weight which is acting perpendicular to the plane would be 4 mg cos alpha, and the component which is acting along the plane would be 4 mg sine alpha. And since the particle P is in contact with the plane, so here we would have a normal contact force which is acting perpendicular to the plane. And since the particle P is in connection with the string, so when I'm referring to the particle P, so the tension in the string is moving away from the particle P. And since the system is going in such a way that the particle P is going down along the plane, and since the inclined plane is rough, so friction would be acting upwards, and this friction would be the maximum friction. It would be called mu r. So mu r will be acting upwards. So as we know that the particle P is going down the plane, so we are going to say that 4 mg sine alpha is more than T plus mu r. So we are going to say that 4 mg sine alpha minus T minus mu r will be equals to mass times acceleration, and the mass of the particle P is 4 mkg, so it will be equals to 4 ma. And then as we know the fact that if we resolve the forces perpendicular to the plane, so r minus 4 mg cos alpha will be equals to 0. So therefore r is equals to 4 mg cos alpha. And you need to make sure that you do not substitute g is equals to 9.8 over here, because as per the requirement of the question, you need to leave your answer in terms of m and g. So first of all, what we are going to do, we are going to find the exact values of sine alpha and cos alpha. So as we know the fact that in the question, it is given to us that tan alpha is equals to 3 over 4. So we are going to find the exact values of sine alpha and cos alpha respectively. So here I'm going to make a triangle having an angle of 90 degrees. Okay, and this acute angle is alpha. So opposite over adjacent. So the opposite side is 3 and the adjacent side is 4. So under this condition, hypotenuse would be under root of 3 square plus 4 square, meaning hypotenuse is under root of 25, which is supposed to be 5. So the hypotenuse is 5. All right. So exact value of sine alpha is opposite over hypotenuse, meaning 3 over 5. And the exact value of cos alpha is adjacent over hypotenuse, meaning 4 over 5. So here we have found the exact values of sine alpha and cos alpha respectively. So as we know that R is equals to 4 mg cos alpha. So therefore R is equals to 4 mg multiplied by 4 over 5. So R will be equals to 3.2 mg. And then we are going to use this R in the equation of motion for particle P. All right. So 4 mg sine alpha, meaning 4 mg times 3 over 5 minus t minus mu r. And since the coefficient of friction is 1 over 4, and in place of r we are going to write 3.2 mg, and this will be equals to mass times acceleration, and the mass of the particle p is 4m. So it will be equals to 4ma. So therefore 2.4 mg minus t minus 0.8 mg is equals to 4ma. And since in part A we found the equation of motion for particle Q, it was T is equals to ma. And as we know that in part B we need to find the tension in the string. So since T is equals to ma, so in place of ma we are going to substitute T. All right. So this will be 2.4 mg minus T minus 0.8 mg is equals to 4 times T. All right. So 2.4 minus 0.8, this will be 1.6. So 1.6 mg is equals to 4t plus t. Therefore, 5t is equals to 1.6 mg. Therefore, t is equals to 1.6 mg divided by 5. So 1.6 over 5, this is supposed to be 0.32. Therefore, t is equals to 0.32 mg. All right. So here we have found the tension in the string in terms of m and g. This is the answer of part B. T is equals to 0.32 times mg. All right. So in part C, we are asked to find the magnitude of the force exerted on the pulley by the string. All right. So first of all, I'm going to write the answer of part B over here. T is equals to 0.32 mg. Okay. And I'm going to erase the working of part B so we can make space to solve part C. So basically the concept is that when you are asked to find the magnitude of the force exerted on the pulley by the string, or the magnitude of the force exerted on the string by the pulley, okay, you will have the same formula for finding the force. The only difference is that in which particular direction the force is acting. So here we have the force exerted on the pulley by the string. So a string is on the top and pulley is underneath it. Okay, so the force exerted on the pulley by the string would be this force. We are asked to find this force. The formula for finding this force is 2t multiplied by cos alpha over 2, where alpha is actually the angle between the two tensions. Angle between the two tensions. All right. And in this case, since the angle alpha is already occupied in the question, so I'm going to say the angle between the two tensions is theta. All right. So those students who have already studied complete mechanics course from me, they already know that we have covered this particular concept in detail in the online classes, and we have done the exam style questions practice from the book exercises as well. All right. So 2t multiplied by cos alpha over 2. This is basically the formula for finding the force exerted on the pulley by the string or the force exerted on the string by the pulley. All right. So first of all, we need to find this angle, and intentionally I've kept this angle as theta since alpha is already occupied in the question. So here we are going to find this angle theta. All right. So first of all, I'm going to make a triangle over here with black pen. And obviously I can find the value of alpha first, since alpha would be equals to tan inverse 3 over 4. So alpha is basically tan inverse 3 over 4. So tan inverse 3 over 4, this is supposed to be 36.8699. So now I can find this green angle. Okay, it will be 180 minus 90 degrees minus 36.8699 degrees. This is supposed to be 53.1301. And now in order to find the angle theta, which we need over here, would be 53.1301 plus 90 degrees. Okay, so the angle between the two tensions, which I marked as theta, it is equals to 53.1301 plus 90 degrees. This angle theta is 143.1301 degrees. So our requirement would be 2 multiplied by t multiplied by cos 143.1301 over 2. And since we know that t is equals to 0.32 mg, so 2 multiplied by 0.32 mg multiplied by cos 71.56505. This is supposed to be 0.20239. So 0.20239 mg, and correct to three significant figures, 0.202 mg will be your answer. So this is basically the magnitude of the force which is exerted on the pulley by the string. All right, so now we have part D. State where in your working you have used the information that the string is light. So the assumption is that the string is light. The string has no mass on its own. It is massless. Okay, so how we have actually used this assumption over here? So according to this assumption, we are going to say that the tension in the string will be same throughout a particular section of the string. So our answer is going to be that the tension will be the same throughout a particular section of the string. As simple as that. So this was the answer of part D, and this was basically the question number 7 of International A-Level Edexcel M1 January 2022 paper.